So this section of the Prentice Hall Algebra 2 Trigonometry textbook is on inequalities. So, in an equation, let's say the equal sign is replaced by one of the order signs, which are less than, greater than, less than or equal, or greater than or equal. Then the equation becomes an inequality. So for an inequality, let's say we have the inequality 3x minus 5 is less than 16. There are an infinite number of solutions that would make this equation true. So often we'll express the solution to an inequality in the form of a graph. So inequalities can be solved very similar to the way you solve an equation. You really want to isolate the variable and get x is greater than or less than to any specific number. So the first thing we're going to do is add 5 to both sides. So we're going to have 3x is less than 21. Then, to isolate x, we're going to divide by 3. So x is going to be less than 7. So, for this equation to be true, you could plug in any number that is less than 7. So the way we show this is by a graph, and we use a number line to show this. So on the number line, you're going to want to show the origin, which is 0, and then maybe a negative number on both sides. So we have -7 and +7. So this solution is any number that's less than 7, so the way you indicate that is an open circle, because there's no, it's not less than or equal to 2, it's just, it's exclusive. So we do an open circle and an arrow pointing towards the negative side. So here's another example of an inequality. Now, this is -2x is greater than or equal to 18. So to isolate x, we would have to divide each side by -2. Now, when you do that and you're working with inequalities, the rule is that you have to switch the direction of the inequalities. So since we divide it by a negative sign, this would become x. Whoops, I forgot to click on the pen. Okay, this would become x is less than or equal to -9. And then we would indicate this on a number line. So if we were showing the number line, we're going to say this is 0. This will be -4.5. This will be -9. And since this is less than or equal, we indicate that with a closed circle at -9 and pointing in this direction. So this next inequality has 3 members. So in order to isolate x, we first need to subtract 5 from each member. So in order to do that, we have to subtract 5 from all 3 parts of the inequality. So to rewrite this, we would have -2 is less than or equal to 2x, which is less than 6. Then we'd have to divide 2 by both sides, or multiply each member of this inequality by 1/2. So this would become -1 is less than or equal to x, which is less than 3. Now graphing that, this would become, if we were showing, this would be -1, this would be 0, and this would be 3. So we would put a closed circle at -1 because that is less than or equal, and an open circle at 3 because that was just less than, and we would connect these. So this next example involves absolute value with inequalities. So remember that the absolute value is the distance away from the origin. So this absolute value is stating like x is a number that is more than 29 units from the origin. So, and that can be from either direction. So for this statement to be true, x could be greater than 29 because that would mean its absolute value is greater than 29, or x is less than -29 because then again it would be more than 29 units away from the origin. So to graph this, we use a number line. whoops, this would be negative 29, this would be 0, and here would be positive 29. So we would use two open circles pointing in opposite directions. So now we're going to look at just the opposite, in that the absolute value of x is less than 29. Now, remember that absolute value is the distance away from the origin, so this is saying that x is a number whose distance away from the origin is less than 29 units. So we could express this as negative 29 is less than, or x, which is less than positive 29, because x could be a number anywhere in between these two extremes and be less than 29 units away from the origin. So to graph this, we're going to again show the origin here. This would be negative 29, and this would be positive 29. And on each one there would be open circles because it is not inclusive, and it would be connected through the center. So this last example deals with absolute value and inequalities, now with restricted domains. So first we're going to solve this inequality, and this is an absolute value with inequality. So they're saying that 3x minus 5 has to be less than or equal to than 13. So since this, we're going to say this is x, like the 3x minus 5 is x, this number's absolute value has to be less than or equal to 13 units. So we can set this up as negative 13 is less than or equal to 3x minus 5, which is less than or equal to positive 13. Then, solving this inequality, we would get negative 8 is less than or equal to 3x, which is less than or equal to 18. And then dividing by 3, we would get negative 8 thirds is less than or equal to x, which is less than or equal to 6. So now we can graph this solution in each of these different domains. So starting with A, this is all real numbers, so this would be the true value of x for this particular inequality. So we'll set this up as, we'll say this is negative 8 thirds, this is positive 6 over here, and on the negative 8 thirds we'll have a closed circle because it's inclusive, and positive 6 would have an open circle because it's exclusive, and we would connect these two. And well, for B, the domain is only positive numbers, so this inequality would then be starting at 0 and ending at 6. Though at 0, since 0 is not a positive number, it would be exclusive at this end. So we would use an open circle here, while at 6 it is less than or equal. So this would be a closed circle. And we connect these here. Going back, I just realized that this was a less than or equal, so this should also be a closed circle. And C, for just integers, we would represent this on the number line showing the integers between negative 8 thirds and 6. So that would be negative 2, negative 1, 0, 1, 2, 3, 4, 5, and 6. And it would be, this inequality would include all these integers, so we would just show it as one closed circle here, 1, 0, 1, 2, 3, 4, 5, and 6. So this concludes the section of chapter 1-6 of the Algebra 2 Trigonometry textbook on inequalities. And of course, all this information can be found on pages 27 through 31 of the textbook. Thank you.